Greetings and konnichiwa from Kyoto, Japan. My name is JJ Price, Global Sales Manager at HACARUS. I'm excited to be here to introduce you to our company and AI solutions for the ASEAN market. HACARUS is an AI solutions provider based in Japan. We focus on the analysis of images such as pictures, video, radar, cell images, and MRI. We also use time series data, which is data measured over time, such as vibrations, sound, electrical current, and temperature. We closed our Series B round of financing in late 2020 and have raised approximately 13 million US dollars to date. And this was led by our main investor, Osaka Gas, a gas and utilities company, and this was used to help fund our global expansion. We currently have 4 offices in Japan and 1 office in the Philippines, and we hope to open more offices in ASEAN to support new customers in their country of operations. Our solutions have 3 unique points of value. One is that we work with small data. In a world where AI is growing increasingly popular, deep learning is arguably the most well-known AI technology. However, deep learning is also associated with the need for large amounts of data in order to obtain accurate results. This has led many companies to have issues adopting AI as they are unable to collect sufficient data. We also provide explainable AI. Whether it's in business or medicine, it is essential to understand the decision-making process that AI models take to make a prediction. Once again, with deep learning, results are hidden behind a black box, neural network, making it impossible to determine why certain conclusions are made. Our solutions provide feedback, explaining the results and reasoning behind its solutions, giving it an edge against conventional AI methods. Lastly, our lightweight AI design that offers high speeds and low power consumption in a variety of environments. For other systems that require large amounts of data, high-spec hardware such as graphics processing units or GPUs is required. This consumes a lot of power and is time-intensive. Making use of its lightweight design, our technology can integrate into your existing system because of its low processing loads. And we're able to achieve this due to our proprietary AI engine based on sparse modeling. The basic assumption of this approach is that most of the features of data are actually insignificant, and that insights can be derived from a relatively small amount of essential information. The formula below is a form of lasso, a key algorithm behind sparse modeling that was first developed around 25 years ago. It became widely recognized in the field of data science, and at HACARUS, we have been focusing on joint development with research institutes such as Kyoto University, as well as application development with our business partners. We were recently featured in Nature for our work in the medical field, where we have achieved 98.7% less energy consumption and 4 times the learning speed compared with conventional deep learning. Another feature is that only the good or normal data is required for training AI models using our approach. As a leader in the AI industry, we have contributed to over 100 customer projects over the past 7 years. Through our experience and technical capabilities, we help firms achieve digital transformation objectives to enable humans to make better, faster, and more reliable decisions based on AI-driven insights. We have worked with companies such as Osaka Gas, Bayer, Mitsubishi Electric, DS Pharma Animal Health, and Deutsche Bahn. HACARUS solutions are used in manufacturing industries such as automobile, electronics, semiconductor, metals, and a few others. We also do work in the medical field in areas for diagnostics and drug discovery. We also have several projects in the infrastructure industry for segments such as energy, utilities, and construction. And these are all key areas in the ASEAN market. ASEAN is important to us because of its strong manufacturing capabilities in a range of sectors. In the graph on the left, from 2015 to 2019, Manufacturing exports from ASEAN's 10 member states averaged 5% annual growth. This outpaces the global average of 3%. While few factories are currently at the Industry 4.0 forefront, there are big new opportunities to become globally competitive by moving early to embrace next-generation digital technologies such as AI solutions. If taken advantage of these trends, it is estimated that by 2030, the region can generate up to $600 billion a year in additional manufacturing output, increase annual foreign direct investment in manufacturing by up to $22 billion, and create up to 140,000 new jobs a year. Shifts in global supply chains arising from trade tensions and the COVID-19 pandemic are also creating opportunities for manufacturers to break into or greatly expand their market share by innovating in existing sectors and shifting to various parts of the supply chain. This market for medical technology and biopharmaceutical products has been growing by around 8% annually and is projected to reach a combined $53 billion in 2024. We want to help companies harness Industry 4.0 technology to create opportunities and to become more globally competitive. Now, I would like to introduce a few examples of how we have made this happen in manufacturing, medical, and infrastructure sectors. In this first use case, I would like to introduce what we did with Mitsubishi Electric by providing AI visual inspection solutions for quality control of manufactured goods. We have saved on average 30% with costs associated with these inspections. All of the operations can be performed locally and is hardware agnostic. It doesn't require a powerful GPU or cloud connectivity to use our AI solutions. And we can also train with as little as 20 images to get started and only require the good data for this training process. Here is a video with a brief summary and demo of our solution called Spectro. Visual inspection is an integrated part of modern quality controls. However, current systems that are based on pattern matching technology are prone to false positives. In fact, in some cases, the error rate is as high as 50%, leading to unnecessary costs and bottlenecks. To enable smarter visual inspections, HACARUS has developed Spectro, the world's only sparse modeling-based AI visual inspection system. Fueled by AI, Spectro can create highly accurate models from small data sets, producing superior insights. For this brief demonstration of our cloud module, let's take a look at defect detection for side mirror covers. To train a model for prediction, simply upload training images using the user-friendly UI. Next, do the same for prediction targets. For this example, I have trained with only 5 images and tested the model on 4 images. Pick one of the predefined algorithms and set the parameters. It's that simple. Processing times will vary depending on the complexity of the images, but usually only takes a few seconds. Once the model has been created, we can use it to spot defects and errors. As you can see, Spectro not only detects the errors, but indicates the severity of defects, using helpful tools such as displaying the various stages of processing, bounding boxes, and a heat map feature. A human user can verify the results to calculate model accuracy by confirming the AI predictions of pass and fail. With flexible deployment options including a cloud module, a box PC version, and on-premise, Spectro is made to solve your inspection issues, regardless of complexity or where it's deployed. Today, award-winning Spectro helps customers enable Industry 4.0 in the manufacturing field. Contact HACARUS today and take your inspections to the next level. Spectro works well for defect detection in a wide range of materials, including wood, metal, and fibers to detect flaws, dents, holes, and breakage. Spectro can also be used in the assembly line to detect missing parts and misalignments, as well as pattern matching to detect deviations from specified object patterns or uniformity for inspections of products such as circuit boards. Spectro is also flexible and can be deployed in several different modules, such as a cloud version for evaluations and piloting, or be integrated with existing systems to run on edge and in real time. We have also created an evaluation kit called Spectral Go that can be used to evaluate our solution. It comes equipped with hardware, including a camera, lighting, stand, and an industrial PC box with Spectral already installed, so you can get started from zero quickly and easily. Here, I want to show how our solution performs against other AI approaches for visual inspections, such as support vector machine and deep learning. In this analysis, Cornell University compared the two solutions for inspections of solar panel surfaces. We used the same data with Spectro and found that we were able to train our models using less than 10% of the data used in the other solutions, while achieving faster training time, prediction time, and high precision. This is the power of sparse modeling-based AI for visual inspection. Next, I would like to introduce some of our medical use cases. The first one on the left was with Mitsubishi Tanabe Pharma to create AI-powered cell image analysis for drug discovery. Utilizing HACARUS's proprietary AI technology, the new model drastically reduces processing time and solves black box issues related to the feature extraction for hit compounds. We were able to reduce the computational time, which takes 20 to 40 minutes per compound, which had to be completed for thousands of compounds, taking months of time. We were able to reduce this time to 16 seconds using one common model that could be used for all of the compounds required. Additionally, we were able to determine which feature correlations have changed and to what extent, bringing crucial explainability into the field. By using this HACARUS unique model, it may become possible to screen a variety of conditions, including disease types and genetic polymorphisms based on a patient's iPS cells. The next use case with DS Pharma Animal Health, where we created an ECG monitoring device for dogs and cats. Traditionally, gathering ECG data from these animals was difficult as they had to be strapped down uncomfortably, which affected the accuracy of the ECG analysis. We co-developed a device that is able to collect vital heart data using an innovative electrode device. The animals stand on the device so that we can gather the data in a non-intrusive way through their paws. We rolled out the trials with partnered clinics in Japan using a convenient 5-minute test. This AI-powered ECG monitoring device provides veterinarians with a simple and effective solution while eliminating the need for complex procedures that stress or agitate the four-legged patients. Lastly, in another project with Mitsubishi Electric, for a collaboration that focused on automating cell analysis lab work, which is achieved by linking HACARUS's AI system and Mitsubishi Electric's industrial robot. The seamlessly integrated solution includes a 3-stage setup, starting with the robot carefully preparing and transporting cell samples for examination by a digital microscope, powered by HACARUS AI. The setup reduces the human resources needed in image analysis and not only provides accurate analysis with less errors, but also increases the volume of experiments. This technology is especially useful due to the increasing demands for remote work imposed by the COVID-19 pandemic, which has affected ability for humans to perform experiments in person. Here is a brief video of it in action. Lastly, I will introduce 3 of our infrastructure use cases. We created an unsafe behavior detection system using video data for construction sites. Here, we are able to increase the safety of workers by detecting helmet, goggle, and glove wearing, as well as looking for exposed skin. We developed a monitoring application that sends supervisors on or off-site notifications and useful insights. In creating this, we combined object detection, human detection, and body part segment detection to create this solution. We were able to complete this using only 25 videos for training, and it is currently deployed on multiple construction sites across Japan. This is an ongoing project where we hope to add other features such as intrusion alerts, fire detection, and other hazardous detections to help keep workers safe. We have also created an underground object detection solution with Osaka Gas that detects gas pipes, water pipes, and electrical cables using ground-penetrating radar with 89% accuracy. In order for a person to achieve this, lots of training and years of experience would be required to analyze the complicated and area-specific data coming from these machines. This creates a lack of specialists that are able to perform this task, causing bottlenecks in the construction operations. With this solution, we're able to reduce this constraint, saving costs and time. Similarly, we use the same approach working with Deutsche Bahn in Germany to detect hazardous materials underground using these ground penetration radar machines. This project is being done 100% remotely between Japan and Germany. The underground object detection solution does not collect data, but analyzes collected data and works with a wide range of ground penetrating radar data, format, and machinery. We can also build a standalone software or integrate the results into your existing software, providing different ways to use our solution in your business. Thank you for listening to this webinar, and I hope that you found it informative. The team at HACARUS is looking forward to working with you and answering any questions you may have regarding incorporating AI to your business. In summary, HACARUS can deliver superior AI solutions using small data, explainability, and that is fast and resource efficient. We are also focused on the manufacturing, medical, and infrastructure industries for ASEAN. Please feel free to contact me anytime for a free consultation and light data assessment to help ready your business for Industry 4.0. Thank you, and I hope to hear from you soon.